My name is Ongun Berk Kazanci, and I'm going to talk about desktop-mounted personalized ventilation systems. I'm an associate professor at the Technical University of Denmark and a senior engineer of building physics at Bureau Happold. And since this topic is very specific, what I'll try to do is basically start from very generic and get down to very specifics of it. And of course, within a 15-minute presentation, it's not possible for me to talk about all the systems that's been done. So we will look at some of the main systems or the major studies that's been conducted. So when we want to look at the indoor environmental quality and the interaction of that between the personalized environmental control systems, the indoor environmental quality, IEQ, consists of basically four main environmental parameters. And these are the thermal aspects, the air quality aspects, the lighting aspects, and the acoustic aspects. And of course, these influence or affect people, but also they affect how buildings perform in terms of energy efficiency and carbon emissions. And what these affect is that they affect the comfort, satisfaction, productivity, health, and wellness of people exposed to these conditions. Then, when we look at personalized environmental control systems just a little bit more specifically, what they do or what they try to do is that they condition the immediate surroundings of the occupants instead of the entire surroundings, as Bjarne also mentioned. So they create a personalized space that is immediately in the vicinity of the occupants. And ideally, PECS should be able to provide individual control of these IEQ parameters that we talked about by being able to heat, cool, ventilate. This could be both fresh outdoor air, or this will be clean air as well, and also by adjusting the lighting and acoustic parameters. And why is PECS? There's been a lot of work being done on PECS, but why is it particularly important and relevant right now? Is that there are a few reasons. This is not all of them, but like as I said, why they're relevant right now is that first of all is the COVID-19 pandemic, which increased both the awareness and also the interest in infection control in indoor spaces. So personalized ventilation can help in this by providing the fresh air more efficiently, but by limiting the cross-contamination or infection spread. Then, of course, due to the climate change as well, and due to resiliency to climate-related disruptions, for example, heat waves or power outages, blackouts, but also to wildfires and outdoor air pollution. And there's a separate IEA Annex 80 working on resiliency aspects. And of course, related to PECS again is the energy efficiency and carbon neutrality aspects. And then, of course, comfort and health of indoor occupants, which then is an interaction of these IEQ factors, as I talked in the previous slide. So the basic idea, or where this the interest comes from, I tried to basically get back to the origins, and there's a quote from Fanger, which basically said that we would hesitate to drink water from a swimming pool that is polluted by human bioeffluents, but yet, or still, we accept consuming indoor air that's previously been in the lungs of other persons and is polluted by human bioeffluents and other contaminants generated in the space. So basically, by doing this analogy, then the idea was to create a system that can deliver the air before that is mixed with the surrounding air, and basically before it's entrained with the room air. So when we look at the personalized ventilation systems, keeping in mind what we just talked about and what they're aiming to do, is that they're aiming at supplying the clean and usually the cool air close to an occupant before it's mixed with the room air. And therefore, and also the working principle is that the most important benefit of these systems is its potential to provide clean, cool, and dry air at the inhalation, which then means at the breathing zone, which is the area that's covering the mouth and nose of occupants. And as we've seen this also in the previous slide, the main difference between, just one second, I'll try to find the laser pointer, is that, so if we look at these two very common systems, that is the mixing ventilation and displacement ventilation, they try to basically condition the entire space, even though displacement ventilation is trying to do it in a bit more stratified, controlled way. But if we look at here, then the personalized ventilation is bringing both the air supply and the terminal device closer to the occupants and trying to provide these clean and cool air to the occupant before it's mixed with the surrounding air. If we look at these different studies in the last, let's say, maybe 30, 35 years, is that they've looked at mainly at the heating, cooling, and ventilation aspects. And if you look at some of the earlier studies, they had more focus on personalized ventilation and trying to identify the individual needs, for example, due to temperatures or ventilation rates, and preferences of people. They looked at different air terminal devices. So these are devices that bring the air to the occupant, and then different systems and combinations. Usually these air terminal devices are used in combination with maybe another cooling device or another heating device, which we will see examples in a moment. And in general, the approaches or the way of evaluating this has been using physical measurements, using measurements with breathing thermal mannequins, human subject experiments, and also, when possible, field measurements. So we will look at some of these studies. As I mentioned, the first one is from Baumann, and the others from 1998, which was at the time a commercially available system, which basically had a system that could bring the fresh air, as you could see, for example, connected to an underfloor air distribution system, and would take the air from there, but also possible to bring in recirculated air. So it's possible to either go full fresh air or recirculated air. And the benefit of that is that if you were to increase the air flow rate for cooling purposes, you could do some of that by using the recirculated air. And then the system also had lighting integrated, so task lighting, and also a heater incorporated. And this system was tested extensively in the field as well as in labs. Then another study, I chose one of the main, actually many studies that's been carried out at DTU by Kaczmarczyk and the others. Here, the authors, they tried to compare different air terminal devices and therefore different air distribution methods. So the first one was a combination of a horizontal and a vertical desk grill. You could see it right here. The second system was a round movable panel. As you could see, this was about 16 centimeters in its diameter. Then there was a more rectangular movable panel. So it basically has the same ducting structure, but the air terminal device itself is changing. Then there was another system that they used the headset. This can both used to provide fresh air, but also to basically exhaust the exhaled air as well. So depending on how the fan operates. And then another system that was tested was the round movable panel and combined with the horizontal desk grill. So what was seen was that, of course, these systems perform differently, but if one of them were to be chosen, the round movable panel had the best performance in terms of providing the maximum amount of fresh air at the lowest flow rates because of the way the flow comes out of it. So after that study, there's been further studies here. Another study from one of my colleagues, Maria Bivolarova, and here we could see basically a smoke visualization with a breathing thermal mannequin, and we could see that the air coming out of it is very efficient and it is able to reach the breathing zone of the occupant and of course, very important, is that it's able to penetrate the human body or the convective boundary layer of the body. Then all these studies led to a study, or to actually a system that was also commercially available. This system was actually first introduced in 2008 or 9. Here we see some photos from a separate from a later study. But this system was, again, it was possible to rotate this and to adjust the around the horizontal axis, basically, to adjust according to people's preferences. And this system has been installed in 4 to 5 buildings, as far as I know. Then some of the studies, as I mentioned, is that these systems are normally combined with other systems. So one example here is a study by Hui Zhang et al., who might also introduce this later, is that a system where there was these type of air supply devices from the sides of the occupants, and then this was combined with foot warmers, but it was also possible to be used in combination with heated keyboard. And then this, again, I mentioned this round movable panel was identified as one of the best systems. So therefore, it was again tested in combination with, for example, with a heated chair, with a heated mat on the floor, but also with an under desk heating panel. And also to be tested, there was another under the table or under desktop air terminal device. And to show that these systems can also be integrated with, for example, existing systems, for example, in renovation of a building, is that here we see a study, for example, that could be integrated in a room where you might have a chilled ceiling, which is basically radiant ceiling panels, or maybe using mixing ventilation, but some part of that mixing ventilation or the needs of it can be converted into this one, where we again have this personalized ventilation system with the round movable panel, and possibly different parts of the room or different, let's say, compartments of the air could be created in a room by providing air from partition devices, for example, as it's seen here. Then before wrapping up, I would like to show one of the examples that one of the PECs that we are working at DTU is we are working on developing a desktop-based system, ideally, which will be able to address these 4 different IAQ factors that I talked about. So the first 2 versions of the system was relatively simple. It's not shown here, but we had an air terminal device. It was basically recirculating the room air, but had the possibility to be connected to ducting, and there was a filter, and then we had different heating panels that were basically trying to focus on different parts of the lower body. Then the second version implemented a relatively simple way of trying to cool the supply air by a Peltier element, and then improve the heating function by trying to test a flexible heating panel, as seen here. Then the third version that we have right now is basically improve the existing 2 versions by incorporating recirculation, incorporating a HEPA filter, and incorporating a UVGI, which is the an air cleaning methodology. And then cooling method, or for basically removing the heat from the Peltier elements, was also introduced, and then was used with a single flexible heating panel, which you could see the system here on the right. Here's the air terminal device. Here's the mannequin. Here's the desktop unit that has the UVGI element, and then the touch screen for system control, and the heating panel right here. And we've done extensive studies on this, both in terms of physical, but also using human subject experiments. So we are planning to further develop this system as one of the possible PECS solutions. Then to wrap up, what we keep on working on developing an improvement of PECS or different solutions with functions that could address these different IAQ factors that we talked in the beginning. Then as one of the goals of Annex 87, we are working on a guidance and a unified method of performance evaluation, installation and operation guideline for PECS, so that practitioners can have enough information and guidance to consider these systems as a standard solution. And there are some things we have to focus on and to address certain knowledge gaps before we can do this. And some of these are the integration issues, both aesthetically and operation-wise and physically. How we integrate PECS with the main HVAC systems. If building codes, regulations, and standards, if they are ready, basically to accommodate PECS or the benefits of PECS brought by PECS. Commissioning and maintenance issues, for example, once the system is installed, who's responsible for it, and so forth. User interfaces and interaction with occupants. This is more on the side of making the systems user-friendly so that it's not so complicated. We know not everyone is indoor environmental quality researchers, so we want to make it available for everybody and easy to do. Then sizing, this is both on the sizing of PECS, but also sizing of the background or the main HVAC systems when there's PECS installed in the space. And of course, there are effects on costs and on productivity of occupants, so that we have a marketing case, or we have a case that we can argue for, saying that this has such and such benefits for the building occupants and for its users. And as I said, these are to be addressed and hopefully disseminated to broad audiences through the work that we do in the Annex and through AIVC and Ventipool platforms. And with that, I will conclude my presentation. Thank you very much for listening.